All right, hey folks. It's so great to be back here at Web Lab. This class was like a really big part of my MIT experience. You guys are gonna have a really awesome IAP. It's a really fun competition. You have so much fun. I'm so excited to see all the projects that you all are gonna build. So my name is Alex. For those of you who don't know, I graduated MIT 2 years ago. I was really active in Web Lab at my time there. It's, again, like a really awesome experience. So it's great to be back in class to chat with you all and teach you a little bit about gaming today. So with that all being said, let's start off with a question. And I'm gonna open the chat here so I can see people. There we go. Okay, cool. FYI guys, this is gonna be super casual. So if you have any questions or things you wanna ask, please, drop them in the chat or etc. I want to make sure that it's super interactive. I try to keep my lectures as engaging as possible, if at all possible. But I thought I'd start us off today by asking you a quick question, which is that how many of you have played this fun little game here called Among Us? And in particular, how many of you are absolutely terrible at it like me? Because I'm really bad at Among Us, and all my friends love playing it. And I go in and I always get imposter, and I always end up losing. It's very unfortunate. Now, games like this were huge, especially during the pandemic, right? We've seen a huge buildup of interest in gaming online. And I'm sure you guys recognize some of these titles, right? So things like, like Minecraft, right? All these different titles were played a lot during the pandemic, and it's one of the big industries that we see today, especially with the conversations going around about the metaverse and everything, right? It seems like gaming is kind of the entry point to that. So it's gotten a lot of attention lately. Even my company, Gather, is based on kind of a game, right? So it's a kind of a play, a gamification of a lot of the ways that we do things in the real world, whether it's collaboration over remote work or events or anything like that. Now, that brings us to our topic of today, which is going to be building a real-time game, a very brief TLDR, right? Game development and design is extremely complicated and one of the most complex topics that we have in computer science. There's so much stuff going on, which is what we're going to see in a little bit. But we're going to try to squeeze all that today in the next 45 or so minutes, and hopefully we can get out a game that we're all going to build together. Cool. So without further ado, let's kind of get into the workshop. So to start us off, I thought I'd kind of do a comparison between where we are today and what real-time games are. So what makes real-time games actually that much different from the cat book, what you guys have built so far in the class? Well, the first is that games have a ton of complicated game logic and game state to worry about, right? In Among Us, you have people killing each other all the time and stabbing each other, and then you can do tasks, all these different things that can happen inside of a game, right? It's very complicated, and more in particular, it's constantly changing, right? Things are constantly updating, players' locations are updating, player states are updating, and your game needs to keep track of all that. And in particular, it needs to be performant about the way it tracks all of that, because there might be many players in your game. The second thing is that you might have really performance needy graphics, right? So this is a clip from a popular game called League of Legends, but you can see that there's smoke effects going on, right? There's color, there's fire, there's lighting effects, all kinds of nonsense that is happening. And a computer needs to render all these things, right? It's very non-trivial. If you compare that to something like Catbook, which is pretty static, right? You have a feed, it basically just updates the list of text, right? And it doesn't update that often. This thing is updating way more often, many times a second, right? And your program needs to handle updating all this graphics. So that's kind of how games differ. And we're going to dive into how we're going to handle these different, different pieces of games versus what we have in Catbook. But maybe we can start off with a pretty familiar diagram that you guys have already seen, which is kind of where we are today, right? So I don't know if you guys have updated the slides since last year, but this is hopefully a diagram you've seen already. It's a user, right? Some client who connects to some backend server, right? So in your guys' case, you're using React to write the client, and you have Node.js for the server. And that authenticates with Google to provide identity verification. And we have MongoDB, which is our database. Cool. So let's look a little bit deeper into this diagram and kind of figure out where our game's logic and everything is going to fit in. And it turns out that we want our game logic and state to live here on the server. Okay, so you guys are going to hear me talk about this a lot today, all right? And if there's one thing that I want you all to take away from today's lecture, it's that game logic lives in the server, okay? It lives in the server and it does not live in the client. And let me tell you why. So let's say you build a game, right? Any game that has some kind of logic and state, and it has some semblance of where players are and all this complicated stuff about how this should work. Now, what is the problem if all that lives in the client? Well, you guys might know from your lectures that there could be many, many clients connected to one instance of a website, right? So for instance, in Chatbook, you could have a bunch of people chatting all together at the same time. Now, if we had game logic and state live on the client, what that means is every single update, every single state change, that's all happening on all these different computers at the same time. So who's the central authority, right? Who's able to say somebody won or somebody moved here? So games need some amount of central authority that's like, this is the ground truth. This is what the game looks like right now, right? And because we want our server to control that, we're going to stick it in the back end, okay? Cool. So what about the other side of things, right? We talked about game logic and state a little bit and where it fits in here. And we're going to code that together so you guys are able to see it in action. But there's the other side, which is the rendering part of this, right? You guys saw during that League of Legends clip, right? All kinds of effects and things like that. Now, we're not going to do anything that fancy today, but we do need something to help us, figure out where to draw things. And for that, we're using a library called HTML Canvas. You guys might have heard this in the past, but if not, don't worry about it. HTML Canvas is basically just a DOM element. We're going to go over it together. But it is able to draw things very, very performantly, right? So it is able to, be able to draw many different frames in a row. And when you draw many different frames in a row, you can get something that looks like this, right? It's just a bouncing ball, but what you guys might not quite be able to see is that it's actually just a bunch of static pictures, like changing really quickly, right? Many, many times a second. And if you change the picture fast enough, it'll look like the ball is animating. So it's kind of like those flip books, you can like flip something and like the dude walks on the pages, right? That's basically what HTML Canvas is doing. And that's what all rendering engines are doing. And in essence, is just changing the image really quickly. So you might ask, well, Alex, why we learned React, right? React is for things like, putting things on screens. Why don't we do that? Well, it turns out that React isn't quite performant when it comes to rendering things 60 times per second. React is much, much better at building these static elements that you guys have seen in Chatbook, right? Updating chats, updating posts, but you wouldn't really want it to update 60 times per second. That's pretty ludicrous, right? Cool. Now, what I kind of want to dive into is a little bit of a funny thing about canvas coordinates, which is that, you guys might recognize this Cartesian plane, right? And this is how most of us think about the world, right? You have y and x, and as y increases, you go up, and as y decreases, you come down. But in canvas coordinates, the plane actually looks like this, which is a little bit weird. You're like, whoa, it's kind of funny, right? 0, 0 is actually in the top left, and the coordinates are kind of inverted. So what this means is as you increase in y, you're going to go down. And as you decrease in y, you're going to go up, right? Which is flipped from what you normally expect. So we're going to deal with this in our rendering code, and I'll show you guys how. Cool. So all of that context figured out, let's talk about what we're actually going to be building today. It's the most fun game ever. It's called Color Hunt. All right, so how this game works is you have your little circle, and hopefully you guys can see this. You guys can see this, yeah? Give me a thumbs up or something. Usually I ask for thumbs up and thumbs down in my classes, but great participation. I love it. Thank you guys. So what you can see here is you have a circle and it moves around on a black screen, right? And the goal of the game is you're just trying to find the spot Okay, and the spot is defined as some random goal location on the screen. And the trick here is the closer you get to that spot, the more blue your color becomes. And the further away you are, the more red your color is. And you're just racing against your friends to see who can find the spot first. Okay, so that's the game. Definitely going to win the golden joystick next year, right? Super, super awesome. And we're going to build it together today. Okay. Okay, so I'll stop here for some questions. I know we just covered a lot of context, but honestly, guys, that was a big chunk of what we're doing today. Is just covering the context, and then we'll do the coding together. So feel free to pop the questions in the Zoom. I know that WebLab also has a questions doc. So staff, if you have, if there are questions in the questions doc, please feel free to pop them in the chat as well. And I'd be happy to answer them before we move on. Any questions? Well, generally feeling good. Excellent. Okay. Well, again, staff, feel free to pop the questions in as they come. Happy to answer them. Make sure I clear up any confusion, because this stuff is, a little bit advanced, and I want to make sure that we're going through it to the point where we can all come out the other end feeling like we really understand it. Excellent. So let's do it together. Let's build it. All right. So we're going to go to weblab.2/color-hunt and click on this URL. Now, before you guys clone, I want to give a word of advice. Don't clone this in Catbook. Okay. So you're going to cd ... get out of Catbook, right? In whatever operating system you're using, and clone this into a different folder. Because if you clone this into Catbook, staff is going to have to look at it during office hours, and then, I'm not going to sponsor next year. It's not going to be a good gig, right? So make sure you guys get out of Catbook before you start cloning. All right, and I will do that with you all. So let's see. So I'll do weblab.2/color-hunt. Don't know how to type. Then I'll go here, copy this, right? Where's my terminal? Oh, it's over here. And then clone this guy. Note that I'm not in Catbook, which makes it nice. And then I'll go in here. Cool. And once that's ready, we'll move on to our normal checkout. So this is going to be like any other workshop that you guys do at WebLab. We're just going to check out starter and then do our npm install and npm run hot loader and npm start. So I'll give you guys a second to do that. I will do that on my side as well. So we're going to do an npm install. And then I'll have two things here. I'll npm run hot loader. And then cd into color here, and then npm run start. Excellent. All right. And then hopefully my code that, oops. So we'll go to localhost 5000. And great, we come into this login screen, right? That means we're kind of ready to get started. Okay, so when you're ready to move on, feel free to look up or give me a thumbs up. Lecturing over Zoom is so tricky, I swear. You guys gotta make it easier for me. All right, so while you guys are finishing that up, let's get a little bit more context on what this code looks like, right? So you guys kind of have the general architecture here. Cool. Okay, so you guys have learned about WebSockets already, right? Socket.io. And Socket is a huge, huge component in games. I'm sure you guys can imagine why, right? Because like you're constantly real-time updating everything that's going on. Right. So just a quick review, the client socket is kind of the interface to the React land, and server socket is the interface to the server side, and these two connect the back end and the front end. And on the left side here, we have React land, right? So all the React components that we're actually seeing. So what kind of things we're going to add here for games? Well, we're going to add quite a few more little components on top of this. The first is a canvas manager. Now, this is not a React component. It's just a file that's going to call a bunch of canvas functions for us. So the canvas is going to draw our game, right? And we're going to see how we do that in a second. The second thing we're going to add is an input module. And what input does is it just takes in all the inputs that user is pressing on their key and sending them up to the server to process. Okay, because inputs often lead to changes in game state, right? It is closely tied with logic. So that brings us to our next module, which is the logic module. And that's also going to live on the server, right? So remember, logic lives on the server, right? So what happens is when a user presses any key, right, you press any input, we're going to send that information through the socket, and then logic is going to parse that information, and then it's going to send back this game state. Right now, a quick note here, guys, because I know all these terms in web can kind of get confused sometimes. Game state is not equal to React state. Okay, so you guys have been learning about React state all week and such. And that's kind of what makes a component work, right? So it's going to make a component update with whatever new UI you want to. Game state is not that, however. Game state lives on the server, right? React state lives in each React component. So make sure you don't confuse these two. And then my next question you might ask is like, okay, that's all good and dandy, Alex. This is awesome. But how does this like red arrow work, right? How are we sending updates back to the client? And I would say, well, that's a great question. So how we're going to do this is we're going to send game state updates 60 times per second from the server and just blast them out to the client, right? Now, this is not the most performant way to do things, right? There's better ways. We could decrease the frame rate maybe. If there was fewer game states, we could probably, update fewer times. But for simplicity, what we're going to do is we're going to take the server's just going to chuck game states, right? Back against the client. So every 6 times per second, the server's like, here's a game state, here's a game state, here's a game state. And the client's like, oh, okay. It's taking them, it's updating the UI constantly, right? So that's kind of how we're going to go from the server-side game state to updating the client. And like Nick said, IO here is just socketmanager.getIO. Right? Cool. And this function sits in our server code. You guys can look for it, but I won't go and cover that today. I've written some of this out for you, so we don't have to go back in and look at it. Cool. So on our graph, what this means is 60 times per second, we're like constantly spamming the client with updates, right? So what is in game state is our next question here. What should we actually be putting in the game state? And I have multiple choice question for you all, like a good lecture. What do you guys think? Is it colors of players, locations of players, the winning state, or D, all of the above? Vote now in the chat. What do you all think? Yes. Okay, so this is one of those questions where I'm like, yeah, you didn't want to write out all the common stand choices, so it's just the all the above, right? Excellent. So yeah, all these things need to go into the game state, right? We need to know the colors, locations, and whether anyone won. So what I'm going to do now is we're going to actually go code that. So I'm going to open VS Code here, and actually we'll close everything out. Should be in starter. And I'm going to press Control or Command P. Can everybody see this, by the way? I'm being a little bit larger. Okay. All right, so I'm pressing Control or Command P, and I'm going to type logic.js. Okay, logic.js. Now, logic.js is, like we saw in the module, that part of the server that's handling all of our game state, all of our game logic. We'll go down here to this game state. Okay, in step 0, we're going to define our game state. So what things do we need to update in here? Well, I'm going to say, well, we need a players, and I'm going to make this an empty object. And what this is going to do is it's going to map an ID of a player to its X, Y, and color. So at all times, the game state knows where the players are and their X, Y locations. Now, before I continue, I'll give you guys a quick note. Please don't feel like you need to follow along and code with me here. We're going to be going pretty quickly because there's a lot of code to cover. So I actually maybe even recommend you guys just watch, right? Watch and kind of absorb. All the code will be available to you online, so you can just kind of pull that in once we're ready. But if you want to, by all means, please feel free to follow along. But I'll probably move reasonably quickly here. So here's the players, right? So we've gotten that all set up. What's left? What's left? We're missing one thing here in the game state. What else are we going to need? Any thoughts? Well, if we look back on our slides, right, we have the colors, we have the locations. So what's missing here, right? What are we going to put in to our initial game state? Yeah, good job. Defeat victory status, right? So some kind of understanding of what the status of the game is, right? And I'm going to call this variable winner. Call this winner, and I'm going to initialize this to null because no one's won yet, right? So it's anyone's game. I'm going to set that to null, and there we go. That's going to be the ID of whoever won. All right. Now, here's the next question here. When should this game state update, right? What events do you guys think should happen to make this game state update? So a lot of these could happen in the game, right? But only some of these things are going to make our game state update. So tell me now in the chat, what are the things that you would expect to update this game state? Yep, so I saw movement. What else? Good. New player, perfect. So we have player moved. We have a new player. What else? Player wins. Good. You guys are missing one more. One more. That's okay. Player loses. That's yeah. So some kind of victory status, right? That's totally right. And a player quits. Good. Good job, guys. Yes, player quits. That's the one that often is looked over, right? But when players quit, you also need to update the game state because otherwise you're gonna have ghosts like floating around. In fact, at the beginning of Gather, we actually had a bug where when people quit, sometimes you would leave a ghost and there'd be like a little ghost Gather avatar that you couldn't connect to, right? So it's really important you clean up your game state when players leave. Cool. So I've written some code to help us with this. And you don't have to go looking for this. It resides in server socket.js. But essentially what's happening is every time a new user connects to the socket, I'm going to call this function called logic.addPlayer. Okay, and how this function is going to work is we're going to do whatever we need to in the logic to add the player. So it's just calling into our logic module. That's all that's happening here. All right, so let's go fill in that function right now. So add player. What should that look like? I'm coding on my other screen here. But what we essentially want to do is we want to make sure this player is initialized to the correct location, right? So I'm going to say, okay, so game state dot players of ID. So find this, we're going to create a new entry and we're going to give it a random location. And get random location is a function that I've defined for you. It's up here. Okay. So it's going to return some object that defines the X and the Y value for us. And we're missing the color, right? So I'm also going to say dot color equals get player color. And what that's going to do is it's going to find the X and Y and the color for us. Cool. And then we also need to remove the player, right? Like you guys said. So that's also in step 0 here. So if they disconnect, right, we're also calling a function called remove player. And we can just say delete game state.players of ID. Cool. So let's do a quick recap. I don't have time. When we add the player, all we're doing is giving them a random location and then calculating the color and updating that. And when they leave, all we do is delete it from our game state. This is very, very standard. Every single time someone joins, you add them to the game state somehow, and when they leave, you remove them from the game state. You're going to need to do it in your own games as well. Cool. So we're adding and removing the players, right? So this is all good. So what happens next, right? If we look back on our diagram here, we've implemented the logic part of things. Now we need to move over to the React land side of things. So all this plumbing I've already written. But what's going to happen next is we need to implement the front end. So we'll press Controller Command P and type game.js. Game.js. All right. Now let's kind of take a look in this file and kind of get our bearings because a lot's going on. But it's just a normal React component. Okay. It's got some state here. Right now, it's the winner state that's set to null. And whenever we update this winner state, we're going to show some modal like we saw in the demo. And then we have this use effect, which is pretty interesting. What this use effect says is every time the server socket sends us something, right, some kind of update, we're just going to call this function called process update. And it's going to happen 60 times per second, right? So 60 times per second, we're going to just be constantly calling this function process update. So what do we want to do here? What do we want to do in here? Well, we're going to call a function called draw canvas update. And draw canvas is a function that I've defined as well, but we're going to fill in the kind of blanks in that function. So let's take a quick look at that. And that's going to be in the next step of our pipeline, which is in Canvas Manager. Okay. In Canvas Manager, you can see draw canvas. And all this does is it takes this game canvas element, and then it, for now, all it does is it fills it black, right? It says, all right, just clear everything on the canvas. I don't want to see anything, right? And then what we need to do is we need to draw every single player that comes onto the canvas, right? So how we're going to do this is we're going to first fill out this draw player function, right? So how are we going to draw the player? Well, we're going to call a function called fill circle. This is a classic canvas function that you can use, right? There's fill circle, there's fill rect, there's, you can add text using these kinds of functions. And we're going to call it with this canvas context, which is, how I mentioned earlier that like canvases are like magic. Yeah, this is a magic component, right? So you just pass the context around and you call elements on this context, right? And what we're going to do is we're going to call it with x, y, and how big do we want our circles to be? Anyone have any opinions? How many pixels? All right, for now, we're just making 20 because that's what I did in my code, right? And then we'll also give it the color. All right, and then now we need to just draw every single one. So in draw canvas, we're going to do object.values, and this is going to go a little quickly. I'll explain everything afterwards, okay? So we're going to, for every single player, what we want to do is we want to take this player, and we're going to draw the player with X, with Y, and the color. Cool. Okay, so what did I do here? It's a lot of fast typing, so let's recap. What I did is for every single value inside this object player's dictionary, right, it's object, we're going to call draw player on each one. So what that's going to do is our canvas code continuously, 60 times per second, is going to draw all the players in the state, draw all the players in the state over and over and over again. And what do we do in draw players? Well, we just build circle. Right? Okay, so we kind of have something that works. Let's see what we did. Right? Let's go check it out. All right. So we're going to go here, give that a nice refresh, and log in. Right? And boom, blank canvas. Huh. Blank canvas. Oh, Steven asked a great question that I'll get to in 1 second. But let's look at this blank canvas, okay? So there should be a player on here. What's going on? Oh man, gosh, Alex must have screwed up his coding. Yeah, well, kind of. So what we did here is we actually forgot something. Remember, this X and the Y are on the Cartesian plane, right? They're not on the canvas coordinates. So we need to convert them over to canvas coordinates before we can draw them. So what I'll do is I'll define some variable draw X and draw Y and convert the coordinates over from X, Y. So draw X, draw Y. And now, there we go. Now we have our circle, right? And every single time it just randomly goes to somewhere new. All right, let me go back to the code so you guys can see that. So all we did was we just converted the coordinates, right? And this convert coord is a function that I wrote. You guys can check it out as well. Go see that function in our starter code. Now, Stephen asked an excellent question, which is that is document.getElementID game canvas fine in this case? Because we've been saying to you all this time that use React, don't use document.getElementID, right? So there are ways you can embed this stuff in React, but Canvas Manager, what it essentially does is it's a JS file, right? So it's completely divorced from React. So the only way to access the canvas from this Canvas Manager is to get document.getElementID, or that's just the easiest way, right? So that's what we're doing here. If you're in React land, you don't want to use document.getElementID. All right, so I'm going to say we can make as X web lab staff, we're going to make an exception to the rule here, right? And we're allowed to get the element when it's the canvas. But don't do this on your divs and other things. You should let React handle that. Okay, that's an excellent question though. Cool. All right, so we've successfully filled the circle. We've successfully drawn players, and guys, we're almost done, honestly. Right? So making this pipeline work, the game state to drawing the game state on the client side is the highest lift that we're going to see. Right? That's like the entire pipeline from start to finish. So back in our slides here, if you want to catch up, you can get reset hard and check out step 1 to catch up to where we are. And I'll stop for questions because that was the most significant step that we're going to do today is step 0. Okay. All right. Any questions? Is anyone super lost, confused? Happy to go over anything that we just did. And staff, let me know if there are any questions in the doc. Cool. Now, I must be doing an excellent job. No one has any questions at all. How do VS Code just autocomplete that comment? Did anyone else see that? Yes. So I have an extension installed in my VS Code called GitHub Copilot, and it's just an autocomplete thing that autocompletes stuff for me. Sometimes it like massively messes up. So you might have seen that like sometimes it like accidentally thinks I should be doing draw X instead of X. So you can't trust it 100%, but it's very useful if you can read the code and then just tap complete it. If you guys are interested in GitHub Copilot, I can post a link in Piazza later. Is it okay to use get element ID in other forms for related cases like smoother animations? Right, so you would almost certainly want to use get element ID. If you're going to do like animations on a game, you probably are going to use canvas. So you want to be wanting to manipulate individual DOM elements. Get element ID is essentially what React is doing, right? So there's a little small differences. React is somewhat performant, but like if you're doing animations, you almost certainly want to do that through CSS, right? So you can animate stuff by nature through CSS, or you want to do it through Canvas. What is object dictionary? Where was it defined earlier? Great question. So let's go back to our code here, and let's actually just trace through everything that we did. Okay. So if we go to Control Command P, logic.js, the player's dictionary is actually defined all the way up here, all the way in the logic side of things. And then 60 times per second, we're sending this entire game state down through the socket into React. And then in game.js, this socket.on will catch that update, which is just the game state, and call process update on it. So now the object lives in here, and then it gets called into draw canvas, right? Please move zoom thing. All right, canvas. And that will then call draw player on each one of the players inside the draw state, right? So this object has been, you know, Mr. Worldwide, right? Traveling the world, starting from logic side and moving all the way to the front end. Okay, so it's defined in logic. Cool. Other questions? Okay, well, we're gonna move on, but you know, feel free to keep asking stuff. And Jane has a question too. We usually use JavaScript to develop games that are in a browser, right? Yeah, so generally you want to use, like JavaScript is a scripting language that runs on the browser. There's lower level stuff that you can use, like things called like WebAssembly and things like this, but there are JavaScript wrappers that help with that. So yes, usually JavaScript to develop these kinds of games. What does objects.values do? Yes, object.values, it basically takes, I don't know if you guys learned this semester, but it takes a object and it iterates through all the values. So let's say we have something called key1, like hi, key2, by, whatever, right? So the object.values of this guy will just be a list called hi and by. So all it does is it just iterates through all the values. And that's what we want, right? Because remember, in our logic, our players is a key mapping to this object. So yeah, it's like dict.values in Python. That's exactly right. Yeah, same thing. And we're gonna use object.keys later. That's like the opposite, right? So it just iterates through the keys. Okay, cool. Alrighty, so we're at step 1, right? Step 1. Let's let's move forward with our coding. And I promise, guys, the following steps are much easier. So what we're going to do next is, just say this. What we're going to do next is we're going to go and work on the movement of our players. Okay, so let's go back to logic.js. So I control command P logic.js. And now I'm going to actually deal with the movement here. All right, so what we've actually done is I've defined a function here called move player that takes in up, down, left, or right. And then we're going to update the game state depending on these different inputs, right? So if the direction is up, what do we want? Well, we want to do game state.players, and this is one of the instances where Copilot messes up, to be 20, right? Add 20 because we're moving upwards. And I'm going to fill in the rest of this because it's really boring, but you know, if you're down, where we're going to go down, right? And then if the thing is left, we should go left. Okay, and again, guys, feel free to not follow along here. This is, you know, just me filling in all the stuff here. X plus equals 20. So this is super standard. Okay, so in all your games, remember guys, when you guys build your games, you're gonna have some kind of function like this that takes in the inputs from the client that a player is doing, and then correspondingly updating game state. So this kind of structure is what I want to teach you today. You have some semblance of an initial state, and we're always gonna be saying that state, and then you have some function that handles updates from the client, and then updates the game state accordingly. In our case, it's just moving. In our case, it's just moving. It could be entirely different in yours, but what we want to do is, depending on the direction that we get, we want to update that player's Y or X value accordingly. That's all we're doing in this section, right? And if we save here, what are we going to see? Well, let's see. Here's a refresh, and you'll log in again. You guys might be noticing I use a cap lock because I'm lazy. All right, now I have movement. Wow, it actually feels like a game. This is crazy, right? But you guys might notice the color isn't updating. Why isn't the color updating? Well, it's because we never made the color update, right? So let's go back in our code and let's make this color update as well. So we do game state.players ID.color, and I've created a function called getPlayerColor. That's just going to update the color for us every single time somebody moves. Okay, so now if we look in our thing, and I'll give you guys like a few seconds or so to copy that if you need to. We can see that boom, the color should update, and it does. Yay. All right, we're almost done. This game's literally almost done. All right, so everything's working. What's missing? What do you guys think is missing? Let's see. Can't find the blue spot, right? Why can't I find the blue spot? Well, because we never defined what winning means, right? So that's what we're gonna do next. But first, we want to catch up. Get reset hard, check out step 2. And this is our last step. So you guys are almost there. Last step, right? And this one's super short, don't worry. All right. So what we're going to do is we're going to take a look at our win condition. But first, actually, let me pause. And I'll go back to my code here so you guys can see it. Questions on this? Questions on this flow. This flow is really important, guys. This flow, moving from client, you take inputs and you update the game state. If you're building a game, you're going to need to do something like this, right? Some kind of input to game state mapping, right? Staff, any questions on the doc? Are we doing okay? Great. Sounds awesome. All right, so let's move on to the last step here. And this is the short one, so we'll be okay. We're going to fill in this function called check win. Okay, so this is another thing that we're going to need to do when our game state updates, right? We need to update our game state by setting the win. And this time, I'm going to use object.keys. So Steven asked an excellent question earlier about what object.values is. Object.keys is just iterating through all the keys of a object, in our case, right? And first, we're going to say, okay, we're going to get this player. Okay, we're going to get this player. So this player is going to be whichever one is currently the one that we want to check for their win. And then if player.x is the goal and player.y is the goal, then what we want to do is set the winner. Okay. So what do we do here? It's basically the same thing as what we did earlier with rendering, except instead of rendering everybody, we're just running through each player and asking ourselves, did this player win yet? Did this player win yet? Oh no, this player didn't win yet. All right, did this player win yet? And we just go through every single person, right? Every time something happens. Now you guys might realize that, wait, we didn't put this function anywhere, right? It's still, we haven't checked the win. Well, where do we want to check the win? Let me ask you guys, right? What do you guys think is the right place to check our win? Good job, Kenneth. Yeah, move player. Move player is an excellent place to put it. You know, there are other ways you could do this that are less performant too, right? You could say like, all right, I'm just gonna check the win at 60 times per second, right? Boom, it's done. Like at 60 times per second, we're just gonna iterate through everybody and check the win. All right, you could do it. Right? It's not the most optimized, and I like Kenneth's choice much better because every time you move is probably gonna happen less in our game than checking players. Or sorry, 60 times per second, right? So let's check in here. And I guess I gave it away by this to do step 2, check win on move. Okay, so you can check the win in here. Right. Excellent. Okay, so the win has been checked, right? Our state has been updated, but we've only done it on the server side. So you're gonna, again, this is a very common game thing. You're gonna do some stuff on the server, and then you're gonna do some stuff on the client to deal with that new stuff that you got on the server. So we're gonna go back to game.js. And you can see here in this process update that we're going to get a bunch of updates, right? So when players moved, what we did is we drew everybody, right? But we also need to check the win. So in here, we're going to say if there is a winner, what we're going to do is we're going to set the winner. And when we set the winner, you guys can see in our React, I've already written this, but if there is a winner, we're going to top this winner modal. That's like, all right, the winner is this person. Yay, it's done. Life is good. Okay. Excellent. Okay. So give you guys a second for that. So we just added this code right here. So we just check the winner, make sure everything is good. Okay, so let's log in here. Let's log in and kind of see what's going on. Boom. All right, I'm really bad at game, full disclosure, even though I was the one who built it. It's probably somewhere around here, right? All right, cool. All right, and you're done. You're done. So you guys just built a fully functioning game in the past like 40 minutes, right? It's excellent. Now, there's so many things you guys can do on top of this, right? Think about it. This game is probably the most jank thing in the world. And Carl, I'll get to your question in a second. But like right now, this game, literally, if you want to restart the game, you have to restart your server, right? Because there's no way to reset the game. So that's something you can add, right? You can't move off the screen, or sorry, you can move off the screen. That's kind of trolling, right? You should be able to like just yeet your way off the screen, right? So you can just go off, right? You are able to just like keep moving after somebody has won. That's kind of weird too, right? You can fix all this. And where should all this logic go? It should go on the server, right? So you want to make it so people can't move off the screen, do it in the server. So all this like rules that apply to the game, they should all go in the server. Carl asked, how do you add multiplayer? Well, our game actually already supports multiplayer, which is pretty cool. So if you deploy this game right now, it's for multiplayer. Because what we've done is we haven't done anything super special, right? We just have a bunch of clients and they constantly send updates to the server. Every time a new player is added, we add the game state and we just spam the game state back, right? So by doing all the heavy lifting on one player, we've actually already supported multiplayer just because sockets are, magical and can do awesome things, right? So this is it. You guys are done. Multiplayer is added. All this stuff is in. We have a fully functional game. Cool. So if you want to catch up with us now and try the game yourself, you can check out main. Right? Reset hard and check out main. And with all that, that's the workshop. You guys did an awesome job. I'm so proud of you. We finished the game in 40 minutes. And let's do a quick recap on what we learned. All right, so first things first. I've said this a billion times now, so if anyone's forgotten, it'll be on me. It's game logic is on the server. That's the first thing I want you guys to take away from this, right? So when you guys are building your games, please, please, please do your game logic on the server and on the client. If I'm judging during judging week or seeing on the hackathon, everybody's game logic is on the client, I'll be very sad. Be very, very sad. So please, please, please put your game logic on the server. The second thing we learned is you use some kind of rendering engine to render your game. So be it Canvas, right? There are other rendering engines out there, but Canvas is the simplest to get started on. So I recommend that for simple things. So that's the easiest way for us to get a really performant game. Okay, and that's all from me. Happy to take some questions. First, I'll give you a quick spiel on Gather. So for those of you that don't know, I'm one of the co-founders of Gather. We were founded about a year and a half ago, or yeah, almost 2 years now. Things move very quickly, blink, and everything has passed so fast. But we're a company that works with presence. So our mission here is to try to make it as easy as possible to get social connection over the internet, right? I feel like today that Zoom doesn't quite fit that bar. It doesn't feel serendipitous. It doesn't feel joyful. And Gather is here to make your online interactions feel a little bit closer to those real life interactions that you can get from just being next to your friend, right? And so we're also sponsoring a prize. I believe it's 1.5K for the team that does this the best. So creates an experience that really creates opportunity to connect online. So would love for you guys to check out our prize, check out our product. It's a really fun time. Our team is about a little under 90 folks right now, I think, and we're hiring a lot over engineering, product across all different roles, client support, everything. So please feel free to check us out, gather.town/jobs to apply for things. Akshaj was an intern with us. He's awesome. We work together a lot. So yeah, hit us up. We'd love to work with folks, especially from my alma mater and web lab. All right, so I'm happy to take any questions now. Anything about game development, anything, web lab, Gather, startups, hit me up. We have like 10-ish minutes, so I'd love to answer any of your questions. It's my favorite part of being here with you all. I really wish I could be there in person, but you know, Omicron's kind of a mood, so. How do you deal with the delay between the input and the actual movement on the screen when the server is far away? This is such a good question. I love this question. You're thinking ahead, right? So in terms of your games, when you're thinking about it for web lab, probably not the biggest deal in the world. You know, you're not dealing with anything that's so high latency, probably, that it's going to be a big issue. But how we deal with this for, like, you know, production apps, for instance, how Gather deals with this is we take a client-side predict of where you're going to move. Right? So let's say your internet's like just terrible, right? So when you walk in Gather, right, you don't actually walk because the game state doesn't know it. The game doesn't know that you walked yet because your internet's bad, right? So what we do is on the client, we say, okay, this person pressed right on their arrows. That means they're going to move 1 square right. So we're going to predict that that's where they're going to go, right? And then we keep predicting this so that there's like no delay. So on the client, we like kind of check the logic, and then the server is still, though, is the final source of truth. So the server is eventually going to update, send back a game state, and possibly overwrite what is on the client. Okay, how do you, okay, what is your favorite part of Web Lab? Excellent. Oh, so many things. Honestly, guys, my favorite part of Web Lab was the hackathon. I love the hackathon. It's so much fun. You guys are going to make a ton of progress on your projects. Staff gets to walk around and help you guys help build these awesome ideas that you have. It's without doubt my favorite part, and there's free food. So it's super awesome. I really wish that, oh, maybe not this year because Omicron, but in previous years there was free food. I really wish I could be there in person to go to the hackathon, but maybe next year. But yeah, it's a really fun experience. You guys should definitely go. It's a super good time to get a lot done on your projects. What kind of work do interns do at Gather? Akshaj can probably answer this better than I can. So Akshaj, if you want to answer, what do interns do at Gather?
I mean, it's the same. Like, I guess there's not really a concept of interns really. It's just like you do what everyone else does. So I was on the events team, so I made a bunch of features for having events on Gather, and it was really fun. I got to work with a lot of really smart people on my team who helped me a lot with. I mean, it was my first time working at a company that did like software dev work where I actually did real work. So it was an amazing experience, and I highly recommend applying to Gather and trying to work there. It's great.
Yeah. Thanks, Akshaj. Yeah, we had a super fun time with Akshaj. So kind of how we think about interns is we basically treat them as full-time employees. So when you intern with us, you're basically just a full-time employee. We don't really have an intern program because we're a startup, right? So this also means, so this comes double-edged sword. First means that we can't just throw you in the deep end. We give you a project, we're like, all right, we're gonna do this together. Boom, we just start working on it. Your priorities could change. It's just like you're basically just a full-time employee, right? That also means we have a really high expectations for your work, right? You're assuming you can work independently. In fact, it's a lot like Web Lab. And I'll try to be able to like speak to this, but it's like, you know, you just work on your product, right? You make it better, do whatever you need to. It's great. Cool. And when making web games, would you suggest delaying putting out a product or just updating the game as you go? This is a good question. I actually had a lot of experience building like random products that failed to launch beforehand, before Gather, right? So I built this game called squarecraft.io where you like run around, you like collect flags and like you do all this fun stuff. It was super cool. But yeah, I mean, I think there's a balance here, right? So for why I bring up Squarecraft is I think when we launched it, we thought it was a really fun game, but it didn't get much traction. And honestly, you really only have one, like you have many opportunities to launch, but you only have one first launch, right? So you want to make sure your product is at least not churning people actively. And the way I speak about this when I talk about this with folks at Gather is you don't want to serve burned pizza. Okay, so pizza is universally really yummy, right? And any pizza is better than no pizza, but you wouldn't want burned pizza, right? So if you're not serving burned pizza, then the approach is iterate, iterate, iterate. So the first version of Gather, it was very, very, very jank, right? It was, I don't know, you only had like 4 avatars to select from. The performance was, you know, terrible, right? And you didn't have that many functions, but the core value was there, right? The core value of walking up to people and seeing them was there. And that's why we shipped it. So I think it's like you should use your best judgment in these kinds of things, but don't ship a product until you have a product that you're like, think brings value to the world, right? And then iterate on top of that. What was it like for you and your friends to start working on a startup together? It was very interesting. In fact, I didn't know 2 of my co-founders, and I didn't meet them in person until very recently because of the pandemic. So we actually worked together through Gather. Like I met them through Gather, and they become some of my closest friends through Gather, right? Which is an interesting, just like a validation that Gather was actually really valuable for our team. I think your founding team is really important. So if any of you are thinking about going into startups, make sure you pick a really good founding team. These are the people that you're going to be spending many nights with, like, you know, up until 5 a.m. debugging issues and like fixing production fires. You better like them, you know, or you better at least be able to tolerate them. So team is a really important thing. For us, we're all engineering focused, so it was nice we were able to speak the same language. But you know, it was also nice because we had a diverse set of different like skills, so that helped a lot in building the product. So I'd say most important, go by gut feeling, right? Make sure you know your friends really well and that you're able to work with them effectively. I think we just got really lucky that we had a really tight founding team. Cool. All right, other questions? These guys curious about things in the doc? Kyle, we'll gather and incorporate VR in the future. And Max, I'll get you a question in a second. So VR, here's my take on VR, and this is a hot take, or I don't know if it's that hot. And this is not obligatory. This does not reflect Gather's view. It's my personal view, right? Which is that I think VR is not there yet. And I say this from the perspective that I think there's a few things. Hardware is an issue. So like, I think like, I have an Oculus. I don't know how many of you guys have an Oculus out there, but like it's pretty heavy. It gets hot after you use it for like more than 20 minutes, right? Especially if you're running a game. And it's like hard to develop on. There's like all kinds of issues with Oculus today that make it so I feel like we don't have the tools today. I think that we'll get there in like 6 to 10 years is my guess, but not today. And also I think moderation is really hard in VR. Like the other day I was in VR poker. I was playing with my co-founders, and there's this like dude came up to me and was like kind of like, you know, kind of like in my face, you know, and being like, "Yay!" And I was like, "Oh, this is kind of weird." And in VR, it's like super weird, right? Because you feel like this, yeah, it was real weird. So yeah, I feel like moderation is really hard in VR. This is why I feel that we should start somewhere that's more accessible, such as Gather, right? Like a 2D thing, super accessible. Everybody has access to it. All you need is a computer or a phone, right? So our play is that we want to be that kind of bridge. I think one day we could go to VR, but today is not a day. What do you think makes a good startup idea? A few things. First, you better like your idea because you've been working on this for a long ass time, right? If you don't like your idea, you're going to churn real fast. So make sure you like your idea. Like if you're not interested in developer tools, I don't care how good the market is, you shouldn't do it, right? The second thing is make sure that there is a demonstrated need for a core group of users. Like you'd much rather target a group of users who are really interested and need your product versus a very large population that might not need your product. So for instance, I would say that it's not a good idea to build Zoom again as a startup, unless you're like super interested in Zoom and feel like you have some value to add that's beyond Zoom, right? If you're gonna build Zoom, you need to build something that people can differentiate yourself from Zoom, because it's really hard to beat Zoom like face-to-face on video. You're just not gonna do it, right? So make sure that your startup idea has value beyond just a better blank, a better Airbnb, a better Uber. It needs to have some kind of thing that people will go to because nothing else like this exists. Cool. Other questions? Did I miss anything? Don't think so. So a couple minutes left before lunch. Anything else that you guys want to ask about games or Gather? Nice. Anything in the doc? What was the biggest hurdle in finding Gather? Good question. Hiring was hard. Like hiring as a startup was hard. I think we're more past that now, you know, past like 50 people, you're kind of just like a company now, things are kind of just going. As a startup though, hiring is really tricky. And especially early as a startup, it's like hard to figure out all these like different things about hiring, like how much equity to give, all these different things that are not building the product. I think we actually had a really good time building the product because we're all like, you know, engineers, and it was kind of very natural. Like I felt like I was just doing web lab for like 4 months. It was actually so lit. Just got to sit around and do web lab for 4 months. It was excellent. Are there any features that you're excited to launch soon? Yeah, lots of super fun stuff coming out of Gather really soon. I think the thing that I'm most excited about actually is our vision for the Gather platform. So Gather today, as you guys see it, is a product, right? So we provide this like video chat service for people to use at conferences in their offices, etc. What I'm most excited about actually is our release of making it possible for anybody to build any Gather experience in the platform. And Akshay knows this spiel because we talk about it all the time in the company because everybody's super excited about it. But essentially what we want to do here is you want to make it so that anyone can build logic into Gather, right? And now I know I said that logic should always live in the server, but what I really meant by that is like logic should live in a centralized location. And we want anybody to be able to define a centralized location to put logic into their Gather space. So here's a concrete example of how this could work, right? You build some kind of thing that we'll call a Gather extension, that's what we're calling it internally, to pilot a dog, right? So you know how Gather has objects and stuff like that, right? So your Gather extension could just make your dog like move. So it could update the map, you know, 20 times per second to make your dog just like walk across the map. It can follow you around. It can like, you know, eat food. It can do whatever. You can take care of it, right? But all these things can be arbitrarily defined by a separate entity that's not Gather. And once we expose this platform to developers, I'm so excited to see what people can build, right? Because Gather has like so much potential to do anything. You could build so many things in it, right? Imagine building Among Us in Gather. That'd be so fun, right? You get to like see your friends as they come close and they stab you, right? But with our platform, we would want to be able to make this happen. And I think that we're getting there. I think in the next year, we want to be able to release some version of this platform so we can start like building on top of it. Internally, we're already using this platform. Yeah. Like Akshay says, we're already building this, internally using this platform to like do crazy stuff. So my team, one of my teams right now is actually working on building an escape room inside of Gather. So, you know, you can walk around, you can solve puzzles. It's really interactive. You like drink potions to turn into like different animals and stuff for one of the puzzles. It's really, really awesome. And all that is being built through our extension system. So I'm very, very excited for that to launch. And hopefully you guys can help develop on it. Yes, imagine this year's theme. Cool. Well, I'll hang around for a little bit. I know it's lunch and I know you guys are super into lunch. So are you guys providing food this year? I think I saw on Piazza that you are providing food. That's unfortunate. But anyways, I want to let you guys go, but I'll be hanging around for a little bit if you guys have any other additional questions. So feel free to hang around, ask me anything. I'll be around for a little bit longer. But it was so great to see you guys. I hope to see some of you at the hackathon virtually. I love helping out there to make sure you guys get your projects going. And if you have any questions, please hit me up on Piazza. I'll be around. So thank you, everybody. And I'll chat with you all soon. Thanks, folks.
Thanks so much, Alex. I really
Yeah, you
appreciate
got it.
it.
It was really fun. I love lecturing. Come back.
Yeah,
I really want to come back as staff someday. I really want to get another staff jacket.
yes, forever
You're welcome,
staff.
folks. I'll see you all at the hackathon.
Also, yeah, lunch ends at 1:15, so we got another lecture. So yeah, see you guys at 1:15.
Cool. That was pretty fun. Oh, wait, Claire, you're not in lecture. I thought you were in 1050.
I moved back to Mass C. I'll come back to 10250 soon.
Okay. I really wish I was there with you guys in person. Sounds like so much fun. Maybe I'll come next year. We'll see.
Yes, back for in-person hackathons and lunches.
I know. Wait, Akshay, you're not graduating, right? You're sticking around?
I am. I actually have to figure that out, but I don't know what I'm doing.
All right, sick.
Maybe
Oh, well, if you're there, maybe I'll see you next year.
that would be exciting.
That'd be very exciting. Yes, we can hang out again. Cool. All right, well, this was fun. I'm looking forward to the hackathon. And yeah, and if there are any questions about games on Piazza, feel free to tag me in Slack. I'm checking it every once in a while, but not nearly as often as I used to as staff. So feel free to tag me in there.
Yes.
Cool. And if no one else has any questions, then I guess I'll just go to my meetings.
Okay.
My meetings blocks. All right. Thank you, folks.